Hey, I'm going to try to show you how to do monatomic ionic bonding. First of all, ionic bonds are between ions. That's a positive and a negative. A positive ion is called a cation ion. The T in it looks like a positive. A negative is called an anion. Okay. You have trends on your periodic table. So if you're looking at your periodic table, the first group, and I'm just going to write G1, those have a positive 1 charge. Okay. The second group, group 2, those are your alkaline. Those have a positive 2 charge. You're going to skip the transition elements that are in the center section, and you're going to go to group 13. Those have a positive 3 charge. That's it for periodic trends with positives. There are periodic trends with negatives. The noble gases are the noble gases do not have a charge. That's group 18. That's the far right. So to start with the negatives, you're going to start with group 17. Those are called your halogens. Those have a negative 1 charge. And we're going to work our way backwards to group 16. Has a negative 2 charge. And group 15 has a negative 3 charge. That's pretty it for periodic trends with charges. You need to write those above your periodic table groups. The groups are the ones that go up and down. And then I'm going to really quickly show you how they bond together. So if you look at sodium, sodium has a positive 1 charge. It is in the first column. Okay, and if we bond that with chlorine, chlorine is in group 17. It has a negative 1 charge. What you're looking for, the charges have to add up to 0. Okay, so we've got a positive 1 and a negative 1, so that equals 0. So the chemical formula for that will just be NaCl. Okay, when you're naming these, you're going to name the first one sodium. That's the first element in it. And instead of saying chlorine, it's going to get an IDE ending. So this one's sodium, and then this is going to be chloride instead of chlorine. You capitalize this first one. You do not capitalize the second one. All right, so let's look and see if this is calcium and chlorine bonding. If calcium and chlorine are bonding, calcium has a positive 2 charge. Chlorine still has a negative 1 charge. Calcium is in the second column. All of those elements have a positive 2 charge. Chlorine is in group 17. All of those have a negative 1 charge. So now we're still looking at the charges. The charges do not equal 0. To make this balance out, you would need another chlorine, another negative 1 to balance out this positive 2. So altogether over here now, we have 2 chlorines. They have a negative 1 charge. So we have a negative 2 charge here, which is going to balance out the positive 2 charge here. Okay, so that means that we need 1 calcium and 2 chlorines to balance out those charges. So the chemical formula for that will be CaCl, and you're going to put a little 2 subscript down after the chlorine to show that we needed 2 of those chlorines. Okay, the name of it will be calcium.
And William, please come to the conference room.
Chloride again. All right, let's look at a couple that are a little more difficult. If we, let's see, let me grab my periodic table. Okay, so if we look at magnesium, magnesium is in the second column. Okay, so it's in the second column, has a positive 2 charge. If we are bonding that with nitrogen, okay, nitrogen is in group 15. Those have a negative 3 charge. All right, so now we have a positive 2 and a negative 3. smallest number that both of those go into is 6. So to get 2 to be 6, you multiply it by 3. To get 3 to become 6, you multiply it by 2. So our chemical formula for that is going to be Mg3N2. Okay, there's kind of a glare on that. All right, so the name for that would be magnesium. And instead of nitrogen, it's going to get that IDE ending, so it'll be nitride. Good. A couple more. We bond potassium. Potassium is symbol is a K. It's got a positive 1 charge. We're going to bond it with phosphorus. Phosphorus is in group 15, so it has a negative 3 charge. Charges have to add up to 0. We've got positive 1, negative 3. All right, so we would need 3 of these potassiums to balance out that negative 3 charge because potassium is positive 1. So now we have 1, 2, 3. So altogether we have a positive 3 charge. And we have a negative 3 charge here. So the chemical formula, you're just going to show how many you have of each one. So we have K3, and then we just have 1 phosphorus, which is a P. The name of that would be potassium phosphide instead of phosphorus. Okay, so any of the endings, when you're doing monatomic ions are just elements that are from the periodic table that you're bonding. So, magnesium to oxygen or cesium to bromine. Those are monatomic ions. You're just dealing with 2 elements that are bonded together. They have a charge. Check the charges. Make sure the charges add up to 0. That's how you know what subscript you need to use. And then the name is always the first element is named. The last element, you just give it an IDE ending. So it would be like nitride, oxide, fluoride, chloride, bromide, iodide, sulfide, phosphide. So those are just some of the common ones that you'll have. Okay. So hope that helps.